Welcome. In this week, we are going to get a deeper look into relational data models. In this particular model, we are going to explore an introduction to RDBMS and learn some of the main concepts that are behind RDBMS and look at ER models. So let's get started. Intro to RDBMS. So what is RDBMS? RDBMS is a software that is used to store, manage, query and retrieve data stored in a relational database system. Right? So it expands into Relational Database Management System. So what all does it provide? It provides an interface between the user, the application and the relational database. It also provides administrative functions for managing data storage in terms of expanding it, provide user access and tune on the query performance, etc. Let's look at some of the main concepts under the relational database management systems. A relation in an RDBMS refers to an entity and its associated data. So some of the example entity for a course, if we have to store course information such as this, is student is an entity, the course, the department that offers the course, etc. are entities. An RDBMS consists of a set of relations which are the tables and their data. The entities are different instances and their relation is organized in the different rows and columns of the data table. By deleting old data and by inserting new data, relations are altered in the database table. So some of the top operations in RDBMS can be called by an acronym called CRUD, standing for creating data, retrieving data, updating the data and deleting the data. So some of the popular relational database management systems are Postgres, MySQL, Oracle, MS SQL, your DB2 in mainframes, etc. So now let's take a deeper look into some of the characteristics of a relation, which is a data table. So in a data table, the values are atomic, which means they are single valued. All the values in a column should have the same data type, right? So you cannot, in a date type column, you cannot have any other string variables or date in different types. Each row is unique in a data table. The sequence of rows or columns are insignificant to the storage of the data itself. So each column has a unique name so that you can address it. And there are integrity constraints that maintain data consistency across multiple tables. So we'll take a deeper look at all of these as we progress along. So now let's take a look at what is an ER model, right? So in RDBMS, the relationships between the relations, the tables, are represented by an ER model. ER model is a high-level data model describing the relationship between the entities. So here, a teacher, an entity, teaches a student, right? So this pictorial way of representing the ER model is easier to understand. It's created essentially before the construction of the database to get an idea of the database. So this is the conceptual data model the ER model represents. So there are attributes like the entities and the relationship are the main components, and the entities and the relationship, or both of them, have their corresponding set of attributes which are descriptive features. There is also some set of mapping cardinalities, such as a 1:1 relationship, 1:many relationship between each of these relationships. So for example, some of the entity relationship model would represent student studies in a school, the student enrolls in a course, the student belongs to the department, the teacher teaches the student. So here are some examples, right? So you can see that we already saw the teacher teaches this subject. Then you have employee belongs to a department, an airplane takes off from a runway, and a student has a hobby, right? These are examples of the pictorial representation of the entities. So now let's take a deeper look at the ER model. So the ER model essentially represents the entity set and the entity type. So let's take a look at entity. Entity refers to the abstract real world reference of data table. It is represented as a data table. So there are entities which are weak, there are entities which are strong. So entities which are weak are entities which don't have a corresponding key. We'll talk about key in just a bit. Whereas entities which are strong are entities which are which have a key associated with them. Each of the entity have a bunch of attributes or descriptive features of the entity, right? So there is the key attribute. So key is a attribute which helps us to uniquely identify a particular row in a data table, right? For example, in a student table, you can have roll number as a key attribute. There are composite attributes. For example, address. Address can be made of street name, the city, the country of the student, etc. Right? So, attribute that can be split into multiple different attributes is a composite attribute. There are multi-valid attributes. Sometimes a student can have more than one mobile number, right? So, there can be multi-valued attribute, and there are derived attributes. For example, if you know the date of birth of a student in your database, then age is sort of derived from it, right? So these are derived attributes. So now let's take a look at some of the relationship type and the relationship set, right? So there are multiple relationships that can exist. So there is degree of a relationship set. So let's take a look at this. So there is a unary relationship, which means, for example, if we just have one entity person, it can also represent a relationship, right? A person is married to another person, right? Whereas if you have an employee, there are some employees managing an employee. So relationship which entails only a single entity is called a unary relationship. Whereas a binary relationship is essentially one which combines two entities, right? Very similar to what the ER diagrams we saw. So employee is assigned to a parking space. So this relationship can be one-to-one or it can be one-to-many. So in a particular product line contains multiple products, right? And then a student can register for multiple courses. So this is a many-to-many relationship because on both sides, so a course can be taken by multiple students. A student can register for multiple courses, right? So this is a binary relationship between two entities here. So here in a ER diagram, usually entities are represented by the rectangular box, right? The relationship is represented by the diamond. So then you have your ternary relationship, which is more than two entities, right? For example, so if you have multiple parts stocked in a warehouse from multiple vendors, so a relationship combines all of it. So a part is shipped by a particular vendor from a particular warehouse, and there is a quantity associated with it. So now let's look at the cardinality, right? So sometimes in a relationship, there is a one-to-one cardinality, which is employee gets a particular parking lot, right? Whereas in some cases, there is one-to-many attribute. So a single company can have multiple employees, right? So that's a one-to-many. So you can see that in a ER diagram, usually this is represented in all of these pictorial forms. These different strokes of lines that you see. Then there is a many-to-many relationship as well. So an employee can be registered under multiple projects. A project can have multiple employees. Let's take a deeper look at the RDBMS key concepts. And key is an attribute or a set of attributes that help you uniquely identify a particular entity. So in an entity, in a data table actually consists of multiple entities, right? Each row is an entity. Okay, so let's take an example of a student table and a department table. So to understand what are the different keys. The first is because in order to understand key need not just be one attribute. So a key can also be a composite key. Composite key is a combination of set of attributes, right? For example, roll number and name can be together a key, or enroll number and name can be a key, right? So composite key is a set of attributes. So now let's take a look at what is a super key. A super key is the set of all attributes or set of attributes that can help to uniquely identify a particular entity. So for example, roll number can be an attribute. Roll number and name together as a set can be it can uniquely identify a row. Enrollment number can be a key. So all of these sets, right? A super key is the set of all attributes or set of combination of composite key that can uniquely identify a particular role. So from that set, a subset of it, a minimal subset of it, which cannot be further broken down, right? Which can uniquely identify is called a candidate key. For example, in this case, if one of your super key was roll number and name, so roll number and name can be broken down into roll number, right? Only the roll number is essentially a primary key, right? So roll number would be a candidate key, enrollment number would be a candidate key. Of the set of all candidate key, there is only one key that is represented as the primary key by the database administrator or the DBA, all right? So in this case, it could probably be the ID of the student, right? So that could be the primary key. All the rest of the candidate keys are called the alternate key, all right? So then you have artificial key. So this is often used when there aren't any keys. So we talked about weak entities, right? So when there aren't any key, but the database needs to uniquely identify a row in order to index it. So there can be an artificially created key, right? An auto increment key that can also be created, which is an artificial key. So then you have foreign key, which is when you are trying to combine data from multiple data table, right? Here in this case, department ID would be a foreign key in the students table, so that you can combine it with the department table in order to get its information. So now let's take a slightly deeper look at some of the RDBMS concepts, right? So we talked about entities, we talked about attributes within an entity. Sometimes there is a need for you to combine some of these entities, right? So this is what we call a DBMS generalization. So let's say you have an entity student and then you have an entity patient, right? So both of these entities corresponds to a person, right? So then you can sort of make them into a person entity. So which is a bottom up approach. You are sort of combining multiple entities into a common entity. So that is called generalization, right? So you have a generalized entity which can have like a category column which could identify which particular aspect entity it is. So the second aspect that we do sometimes is your specialization. So a particular employee can be a developer or a tester, right? So in that case, so sometimes you might need to break an entity into multiple specialized entities. For example, as the diagram shows, an account can be broken into a savings account because the set of attributes may be different for a savings account versus a current account. So finally, then you have your DBMS aggregation, which is essentially the combining of entities, right? Sometimes, depending on why you need your database, multiple database entities can come together. For example, a center offers a course, the visitor inquires with the center, right? So the center, course, and the visitor sort of can be combined into a particular entity for easy access. So we'll talk a little bit more about this in the subsequent modules to see what are some of the good practices of database design. So now let's take a look at how do we reduce your ER diagram to a table, right? This is essentially how it would look. So your entity is essentially a real life abstract aspect like your student, your course and department. So then we had an ER diagram which talked about, hey, the student studies a particular course, right? So it shows the relationship in a pictorial way. And then finally, you start looking at trying to get the table aspect of it, right? So now you have a student table that corresponds to the student entity, a course table and a department table, and each of them have multiple attributes associated with it. So just to quickly refresh, so there can be, each of these attributes can be composite attributes, there could be multi-valued attributes, etc. as well. So to summarize this module, in this module we had looked at the introduction of relational database management systems and some of the key concepts, right? Some of the characteristics of a relationship, what are the different types of keys that are involved in RDBMS, etc. And we also looked at ER diagram. It is essentially the entity relationship diagram, how the entities are connected. What are the degrees of a relationship? So there could be just an entity connected to itself, like a unary or a binary or a ternary relationship, and the cardinalities of the entities, right? So I'll see you in the next video. Thank you.